Hello, everyone, and welcome to SPE Live. I'm your host, David Gibson. All right, on today's SPE Live Tech Talk, we are here with OneSubsea, a Schlumberger company. We'll be discussing vertical tree platforms adapting to project dynamics. Now, this episode is obviously live, right? We want you, the audience, to be able to interact with us. This is the whole point of us being able to do it live. If it wasn't live, it'd be a podcast or an article, right? We want y'all to be able to throw out your questions so we can ask the experts and be able to get their thoughts and opinions on it. That's why you guys are tuning in. So please be active in the comment section. Just let us know where you're watching from, and definitely throw out some questions. All right, changes in the oil and gas market are leading to companies to focus more on cost efficiencies. Also, under the microscope, responsiveness and management of smaller teams. During this broadcast, we will focus on finding an agile approach to subsea production systems, how to standardize while remaining flexible, and the technologies that help us achieve those goals. This should be an amazing conversation today. Joining me for this Tech Talk are James Stewart and Phillip Theriot, both at OneSubsea. James is a subsea production systems account manager, and Phillip is a tree and wellhead product champion. Welcome to the SPE Tech Talks. Thank you guys for joining us.
Thank you, David. Great to be here.
Thanks, David.
Audience, this is your chance. Let's see what you have to say in the comments. Share some of the main subsea obstacles you've noticed operators are dealing with, specifically given the challenges over the last few years. All right, James, we'll start with you. James, if you could start us off by sharing your list on this topic while the audience is giving us their responses.
All right. Thanks, David, and good morning, everyone, or good afternoon. Great to be here, and thanks for joining us on this talk. So I think it's fair to say that as we look at our industry, we've been in some pretty unprecedented times over the last few years, and perhaps part of that is the downturn in the oil and gas industry that we've experienced, probably the longest and deepest downturn that we've ever seen. And just as we start to see the green shoots of recovery starting to come through, then we went into this period of COVID, which had a huge global impact to many individuals and families, but also our industry as well. So, like I say, I think we've had some pretty unprecedented times that have really impacted our industry. And some of the challenges that we see because of that have been challenges that we've been around for a while, and some of them are new. But I think certainly the drive for cost efficiency is a massive challenge that we continue to see. How do we, manage to reduce costs and continue to be effective as businesses in this time? I think the big question of cost and how to reduce it, that continues to be a big challenge for us. I think we also see the operators that we work with are needing us to deliver quicker. They need to be more responsive in looking and assessing opportunities and then exercising those opportunities. So the operators want us to be able to be in a position where we can respond quickly. And that's both to engineering and technical questions, but also to delivering equipment as well. So a real drive for us to push pretty hard on the flexibility and the schedule aspect. What we also see, and I guess we've seen this as suppliers to the industry, we've seen times where we've had to reduce workforce, but I think what we've seen over the last year or so is that even the operators have had to reduce their headcount as well. And so we see smaller teams across the industry, not only smaller teams, but people who've been around for many years and have a lot of experience have moved out of the industry. So there's a younger group of people working in this industry, and we have to manage how do we execute the same projects using fewer people. Okay, so another challenge. And then I guess one other area here is the operators have typically projects now with smaller well counts, which is good on one hand because the operator can manage their cash flow more effectively and ease their capex to a degree. But when we have a smaller well count projects, it means some of those fixed costs, like perhaps engineering or some of the tooling that would be required for a project, it's more difficult to amortize those fixed costs over multiple wells, right? So some of those fixed costs become more significant on a project. And then finally, and I think, we've seen the rise of this over the last few years, a real massive focus on sustainability, all right, across the whole industry. And you see some massive changes occurring because of this. And so, we see the continuation and the evolution of how we become more sustainable in our industry. So, there's a handful of challenges that we see as we've, moved through the last few years.
Wow. I mean, that's definitely a handful of challenges, definitely challenges I don't want to have to take on, and I'm even in this industry. All right, Phillip, how are companies responding to those challenges? And feel free to share some of the OneSubsea examples.
Yeah, so when you look at a lot of the challenges we have with regards to, fixed costs and dealing with change, and how do we drive a more consistent approach to solve our clients' problems? I think a lot of people are going to standardization, right? How do we standardize on products to lower the fixed costs from delivery to delivery with regards to engineering, tooling delivery, and so on and so forth. But right, we also have to recognize that we work in an industry, we work in a space where there's inherent variability, there's inherent variance in the environments that we install equipment in, right? Whether we're installing equipment in the west coast of Africa, or in the Gulf of Mexico, or on the Norwegian continental shelf, between subsea topographies and different water depths, that could drive significantly different product architectures that we have to deal with. So, the answer that we wanted to highlight was standardization, but it's also recognizing that it's a bit at odds that we have to allow both standardization and flexibility in equipment to coexist within the same product offering. Does that make sense?
So process is obviously very important. So are you guys setting up a standardization for remaining flexible? Is that what?
That's the key challenge, David, is how do we have a standard platform, all right, which tends to imply you have one thing that you're going to offer. So how do we have a standard platform yet maintain variability for all these different specific projects that all drives different requirements, right? How do you have one solution for everybody? That's the big challenge that we're facing.
Wow. All right, so let's get a little bit more into the technical. Talk to us a little bit about the features and benefit of OneSubsea's configurable vertical tree platform. And we're not talking about trees in your backyard, obviously. And audience, you may want to be taking notes to craft questions for the upcoming Q&A on this one.
Yeah, so the idea behind our configurable vertical mountable tree platform, again, it's really about driving efficiency in our delivery through consistency in design and packaging, right? And it's solving that problem of how do we allow standardization to coexist with flexibility off of the same offering. And the idea was that, like James had highlighted earlier, we didn't want to construct a product architecture that was optimized to suit the high end of client needs or the low end of product needs, because then we would leave a gap in value offering that we'd be able to serve with that type of a system. So we wanted something that we had a common core technology that was consistent across the board, and then we had modular features in the product line that we can scale to serve the different levels of technical complexity that we see in the reservoirs that we play in, right? So features that we commonly see differentiation on from project to project is, the pressure, the reservoir pressure that we will be servicing, whether it's 10K or 15K. The size of the bore changes oftentimes if it's going to be a gas well or an oil well. So a 5-inch bore or a 7-inch bore. Depending on if you're shallow water or deep water, you may have to have a lower profile of system to deal with overtrawlability or fishing friendly requirements or what have you, right? So that's where we need to be flexible in the type of well jumpers to tie the tree itself or the reservoir back into whatever the distribution system is going to be, whether it's directly into what we call a plet, like a pipeline termination, or into a consolidation manifold to a drill center. So that might drive a difference in whether we're going to go with a horizontal type connection system that's a bit lower profile, or a vertical type connection system that might be a little easier to install, right? But it's higher profile, so it takes up more vertical space in the reservoir. We also see a lot of differentiation in terms of the type of flexibility people want in the production flow path, right? So exactly what we're doing to service and orient the flow that's going through the tree, whether it's going to be used for injection into the well or production out of the reservoir. That's going to drive some changes in the instrumentation that you have in the production flow path. And with these changes in production flow path, if we're not careful, if we're not very strategic in how we go about doing the packaging, this could drive significantly different product architecture. So we've worked to eliminate that, right, by offering a configurable flow path while leveraging the same core technology. And then finally, the other point that I want to hit on is tooling, right? So one aspect of it is the product architecture that we're installing permanently subsea. The other part of it is the tools that we use to install that product architecture. And the tools can be a significant investment in the overall campaign. If we can drive, and what we've done is we've driven a consistent tooling suite across the board, whether we're going with a tree directly on a well, whether we have a different wellhead interface, whether we have a 10K or 15K system, we have a common tooling suite so that the client doesn't need to reinvest for future project campaigns or parallel project campaigns or what have you. And then we've constructed the tooling suite in such a way to enable integration of future technologies like all electric systems, so that again, the amount of reinvestment necessitated in this type of system is minimized over the lifetime of the product lifecycle.
So I guess, a bit of summary there, because Phillip touched on quite a few really technical aspects.
I didn't have time to take all the notes. Sorry.
Right. That's all right. The way in which we've tried to, address a lot of those challenges, and Phillip talked through a lot of the details there. The way we've tried to do this is to have a standard configurable solution. And, Phillip talked in the details. I'm going to talk at the simple high level here. I see this in my mind as, in the past, every project we've worked on has been project specific, right? That means every building block of that project we've designed from scratch. We've had to make sure they fit together, and then we've configured the system from scratch nearly every single time, configured specifically for that, or designed specifically for that project. What we now have is effectively standardized building blocks, and I sometimes like to call them like existing Lego blocks, and that Lego block has already been designed. It already fits. We know it already fits together with all the other Lego blocks, right? Those interfaces have been validated and checked. So we have existing Lego blocks that we can now take that are standard. We now take them, and now we can just configure them to the requirements of the specific projects. So that gives us this standard configurable platform that enables us to do things at lower cost, to do things more quickly, to have improvements in our reliability, to be able to deal with smaller teams because we don't have as much details to work through, and allows us to configure it for requirements now and requirements as we move down this sustainability path as well. So that's the sort of simple way in which I understand this system. It's a set of building blocks. Now, not only do we have the building blocks that are existing and designed, but we can also have these building blocks that are at various stages in the supply chain pipeline, right? So we can have them that are just designed, or we can have them at some various stage of manufacture where we can, call these off and assign them to a project as we're going along. And that means we can respond far quicker to what we've been able to do in the past. So yeah, Phillip talked through a lot of the details there of the different, configurations that we can have, but it means we can talk to an operator very quickly, come up with a solution that is essentially field proven, but their specific configuration is built from existing field proven technology. We're pretty excited about it, and we think it really has a lot of benefits.
Well, your excitement definitely shows through, and nothing's worse than having a ununiform plastic brick that doesn't fit with your Lego set. Those get thrown out instantaneously. So
imagine designing those Lego bricks for every single thing you built in Lego. It'd be a nightmare, wouldn't it? But that, as an industry, to some degree, is what we've been doing for a lot of years, and we've now kind of recognized there's a better way of doing this.
I think Lego bricks is a great example of standardization with flexibility.
Right there, yeah.
I mean, I mean, maybe our entire industry should just take on that moniker that we're trying to reach the level of 6-year-olds playing on the carpet and leaving out plastic bricks at night for me to step on. Right. All right. So where is this in development? Are we talking like, is this at a concept stage? Are we testing? Are you guys doing case studies, use studies from the field? Where have you guys reached so far?
And I have a video that I wouldn't mind sharing that does help to illustrate a lot of what we've talked about, probably put a lot of the technical jargon that I had spouted out earlier in a bit more context, right, in a more illustrative form. So again, what we're looking at,
videos,
right? It's a configurable vertical tree platform. What you see here is how we typically construct our subsea product architectures in the form of drill centers, right? So you'll see you'll see a field have multiple drill centers, and the drill centers will be used for different purposes, sometimes injection, sometimes production. And these drill centers will have trees surrounding, these are the trees on the outside, surrounding a manifold that get piped back into a subsea pipeline, right? This is a simplified architecture for illustrative purposes. If we zoom into the field itself and then eventually remove the remainder of the product architecture to highlight the trees, what you'll find is that oftentimes we see different product architectures for trees within the same field, depending on what the purpose of the tree is for, right? Whether it's injection or production. So what we wanted a product platform that we can drive consistency both within the same subsea field, right, and for cross-product applications as well. The way that we did this, again, was we worked to standardize on the core technology of the tree. So if you look at the heart of the tree is really the production flow path, right? What the part of the tree that's closest to the fluid being transported, whether it be hydrocarbons or injection fluid. So we've standardized on this common core for tree technologies that you see in front of you, and we developed it in such a way that the additional product architecture to where these can be modular and interchanged depending on the ultimate product need or application, or tailored to suit client preferences as well, right? The way that we've done this is we've simplified it into its individual building blocks. In this instance, we have modular options for your well jumper, again, whether it be a vertical well jumper or a horizontal well jumper, as highlighted on the left-hand side. This same tree can be customized for your preferred wellhead interface, whether you prefer to land it on an intermediate tubing head spool or directly on a wellhead. And then we also have a variety of different flow path modules as well. Again, just going through a few different configurations to highlight the flexibility of the system. What you'll note is that while we have flexibility in the system, we're also able to maintain a common product architecture, right? Because those bits of customization happen locally within the module that's being changed. So the production flow path is customized within the production flow path portion of product architecture we've already allocated to it.
So is there an option that also comes with leather seats?
Not yet. We're working on that.
So
more for customer to come.
How many different configurations are there? Because I mean, obviously, most people know I'm from the drilling side and directional drilling at that. So once we TD the well, I pretty much know nothing of what takes place after that. So this is a completely new area for me. How many different possible configurations could there be there? And is there the possibility that, you know, if with this system, if they were to change from, it being a producing well to an injection well, could they change this after the fact, or could they change it during the course of, I know a lot of the offshore drilling projects, these are long-term built-out projects. They're making a lot of decisions, a lot of planning in advance. Could they get halfway through the project planning process and then say, oh wait, we need to change this one, needs now, offset well performance or whatever, and now this one needs to be an injection well instead of a producing well? Does this help them in having that flexibility as they go forward, either in the planning phase and or in once it's gone to operation?
Absolutely. This brings a huge amount of flexibility to when decisions are made. And sometimes, like you said, David, the operators are struggling because there's decisions to be made. There's inputs from different parts of the business, and they're trying to make decisions, and sometimes those inputs are not there in time. This allows us to be more flexible, right, and to accommodate and be agile to what the operators need us to do. All right, and that's a real key part of this. So when we have that constant collaboration with the operators, when we understand where they're going on this, we're able to really work closely with them to come up with solutions that really meet their requirements, and that we can deliver. Like I said earlier, we can deliver to a schedule, sometimes a compressed schedule that really helps them get to first oil. But not only does it allow us to move, with agility, it allows us to have predictability with our costs as well. And that's a really important thing that, no one wants to have a project and suddenly the just costs spiral out of control. We're able to, because these are design modules, we're able to be very clear and predictable in what our cost buildup is. This is not something we're designing for the first time and saying, well, let's go to our vendor community and see what the cost of this new device will be. These are modules that we've got real clarity on what the costs are. We know exactly how long it takes to manufacture them. We've in many cases had these components installed for years, and so we're very clear on the reliability of them. And that has a real big benefit because when you understand the schedule and the costs and the reliability of a system, it makes you as an operator not have to keep money in the project. You can use that money for other things. You don't need to use it. And then from a reliability perspective, that's really important because first of all, no one wants equipment that stops functioning and is unreliable. But even from a sustainability point of view, because we have such reliable equipment, it means that when we have an operator in the field, it means they don't have to charter vessels to come out and make unnecessary repairs, right? So this is a real benefit from a sustainability aspect as well.
All right, so we do have an audience question here. We've got a couple of minutes remaining, so we'll have to be quick on this one, okay, guys? Okay, 2 audience questions. All right, so glad you are focusing on reducing production costs to optimize operation. What can oil and gas companies do now to get ahead, and how can you leverage AI in your own operations?
With regards to oil and gas companies and the operator community, this is something that we've been in, again, close collaboration with our client base over the course of the last 5-6 years. Standardization is a journey that we at OneSubsea have been on for over half a decade with value engineering and standardization and blue box optimization efforts that we've had ongoing. That's going to continue to move forward with industry-wide initiatives like IOGP S561, which is a cross-collaboration effort between the operator base companies like Chevron, Exxon, BP, Shell. There are a lot of people that are involved that are working to align on a more consolidated standard, right? To align on what the core technologies need to look like to enable companies like us, OneSubsea, to develop these common product architectures with which we can develop a robust, flexible platform to deliver more quickly. And then on the next side, with regards to AI and artificial intelligence, if you notice, a lot of what we're doing is enabling these configurable options so that we can port them into softwares to enable ease of access to the technology and ease of development via AI or digital type programs, whether it's like our Subsea planner software, which allows a simplified approach to early product architecture development and optimization, or on the back end, in situ monitoring of reservoir and basin flow rates and things like that, to be able to optimize flow using softwares like we have Subsea, a Subsea plan on the front end, and Subsea Live, which enables in situ monitoring and optimization of reservoir systems.
Hey, David, I just want to mention one thing as well here. And I think this is a question you touched on earlier, and it was around, is this something that's just the concept, or is this something that can be, used today? And we are right now using this platform on 2 major projects, a major project in Brazil and another project in the Norwegian continental shelf. So these projects are being delivered right now, and we're tendering, multiple projects in Brazil and South America, in the Gulf of Mexico and in Australia with this exact platform. So we see that this is something that the oil and gas companies are adopting, right, and using and recognizing the benefits of. And as Phillip talked about, some of the uses of AI, we can use this to gather data and process that data and use that to be more efficient.
All right, so we have a question here from YouTube. Arafin Mahad Zaid says, how does the XMT adapt to the pipe it connects to? I'm asking this one because it makes absolutely no sense to me.
Yeah, so we have a connector on the outlet of the subsea tree, which is a mechanical connector, and that connects to an interface on the pipe. And so we have a whole range of equipment that we can use for different size connections, but essentially there's a mechanical connection that connects onto the pipe on the outlet of the tree, and that gives you a mechanical and a pressure containing connection. That's simply how we do it. Imagine an oil field connection for the garden hose, right? It's a similar sort of thing, simplified.
I mean, if we could all just adapt to the Lego and water hose in the backyard business model, I think we'd all do fairly well. But then next week, somebody else will come out with a new mousetrap. Phillip and James, thank you guys so much for being here with us today. We're getting right here towards the end of our time. One last little quick thing from me. What else do we need to know?
We've covered a lot today, and perhaps we could talk about where we find more information. People, please be welcome to get in touch with us, or you can get more information at our website, www.onesubsea.slb.com/Agile SPS. So if you got all that, that would be great.
Well, thank you guys so much for being here. And whenever you guys do get around to creating the leather seat option, please call that the Gibson line item, just like Gibson package, right? Right. And that one's going to cost like triple what the normal price is, because that's just the way things work. And you guys can send the check in the mail. All right. Today's SPE Tech Talk was brought to you by OneSubsea, a Schlumberger company. Thank you so much to Phillip and James for being here. Look forward to see you guys live on the next one.